let's graph these inequalities. I'm going to try to graph as much as I can in slope-intercept form, meaning if you need to solve for y, solve for y. Good news with these first two examples is they already solved for y for us, so I don't need to do that. When you're graphing an inequality, there's really only two differences compared to when you're graphing a line. First difference is you got to be careful with whether you're using a solid line or a dashed line. Just like come on, dash line. There we go. Just like if we were doing graphs on a number line, we've got either a filled-in circle or an open circle. The same rules kind of apply for inequalities. If you see the equal to bar, go ahead and use a solid line. If you have just a greater than symbol or just a less than symbol, there's your dashed line. So that's what we want to keep in mind. The other big difference is whether we are or that we are shading our solution. So let's go ahead and graph this line just like we've learned with slope-intercept form. So my 3 is my constant, so that's my y-intercept. Go up 3 and put a point. And then we have a slope of -2 or -2 over 1. So I have a rise of -2, so count down 2 and forwards 1. And keep doing that as many times as you want to, down 2, forwards 1. Or if you want to, count up 2 and backwards 1 and up 2 and backwards 1. Now, since we have an equal to bar, we are allowed to have a solution that's on this line. So take a ruler or edge of a calculator, don't freehand it like I'm doing, but make that line, oops, I totally missed, but make that line as straight as you can. Try to use a folder or a calculator, and there's my solid line. Now that line represents all the solutions, but I have more because I need to go ahead and shade this. So two methods you could use. You could use the test a point method, where pick a point on one side of that line. So for example, 0, 0 is an easy point to pick. And if the line doesn't go through that point, and then plug in those values for x and y. If you get a true statement when you plug in 0, and let's actually test that real quick. So if I plug in, oops, too many parentheses. If I plug in 0 for x and y, I get a statement that says 0 is greater than or equal to 3, which is false. That's not true. So what that tells me is I'm going to shade the entire, I'm not going to shade that side, I'm going to shade the other side of the line. So I would shade all this, meaning all those points also represent solutions. If you plug in your point and you get a true statement, then shade that side of the line. Now that's one method that totally works out just fine. The method that I like to use instead, though I think is a little bit quicker, is this. As long as your line is in slope-intercept form, which it is, put your pencil on the line. Now, according to my inequality symbol, I want to shade where the y is, and that says y is greater than. So with your pencil on the line, greater than means up, above the line. So put your pencil on the line, draw up. Put your pencil on the line, draw up. Put your pencil on the line, draw up. And we can see it's going to point to that same side where we're going to shade and get our solutions. Okay? Don't think left and right when you think shading. Think above or below, whether we're above the line or below the line. If you think you got it, go ahead and pause the video and try this one on your right. Otherwise, if you want to see it, I'll go ahead and do that right now. So we're in slope-intercept form, so I'm going to just graph with what I remember about this. I'm going to count down 1 and put a point. That's my y-intercept. And my slope's 1 over 2, so count up 1 over 2, up 1 over 2, up 1 over 2, and so on, or down 1 and backwards 2. Once you have enough points, go ahead and get your ruler, your folder, edge of a calculator to make that line. I don't have one to use on my iPad here, so use one on paper, though I'm going to just freehand it. I'm going to go ahead and draw my line. And I've done something wrong already. Hopefully you've caught it. You figure out what I did wrong. Are you talking to a video? That's weird, but good, I guess. So what I did, and I always did this in high school too, I forgot to make my line dashed because I'm not allowed to be equal to the line. So what I would do if I did this, I would just go get my eraser, and oh good, it worked. Go back and just erase parts of my line so I have a dashed line, but I'm not allowed to be equal to that line. Again, we're not done. There's one more thing, and that's the shading. You can test the point like I showed you. Otherwise, my trick is, as long as you're in slope-intercept form, put your pen or pencil on the line. This time it says less than. Less than means below, so while you're on the line, draw straight down. While you're on the line, draw straight down. While you're on the line, draw straight down. And that will tell you which side to shade. So all our solutions lie on this side of the line. Let's take a look at these two. These are just real quick ones, but I want to mention one thing about them. We've got two special lines here, a horizontal line and a vertical line. Remember, when y is by itself, we have a horizontal line. So count down 1 space and then draw a horizontal line. And I'm going to make that dashed because I'm not allowed to be equal to the line, just greater than in this case. So there's my line. Your shading says greater than. Again, my trick was put your pencil on the line. Greater than means up above. So all the points up here would be where I shade. Nothing really tricky with that, but the reason I put these on here is because I wanted to mention the vertical line. The x is less than 3 lines. So vertical line. So count 3 spaces on the x-axis, draw a vertical line. Do you know why it's solid? Hopefully, since we're allowed to be equal to, since we're allowed to be equal to, we can have a solid line. And then the reason I mention this is because this is where my trick doesn't quite work. We want to shade, or what I've been saying is we would shade where, below the line. Well, how do you shade below a vertical line? You can't. But most people figure out you can't shade below, so less than is going to be to the left, where all the negative numbers would be on a number line. So in this case, that's why I wanted to mention. We can't shade above or below, but we can shade to the left. Alright, and then just one more of these I want to show you, and that's when we're not in slope-intercept form. I'd recommend you rearrange it. You can graph these in the form they're in, but for my trick to work and the way that I like to graph is I want to solve for y. So I'm going to do that first by subtracting 5x from both sides. So I have a negative 2y. Don't flip the inequality symbol. So make sure it stays opening up towards the y. Is going to be, once I move that 5x over by subtracting it, I have negative 5x and then positive 4. To finish this and get y by itself, I'll need to divide all my terms by negative 2, and hopefully, since we're working with inequalities and we just said divide by negative, hopefully that alarm went off in your head and that reminded you, or that told you that I need to flip the inequality symbol at this point. So divide both sides by negative 2, flip that inequality symbol around. I can simplify negative 5 over negative 2 to positive 5 over positive 2. I'll put my x on the side, and then minus 2. So there's my rearranged equation. From there, let's do what we've been doing. So I have a y-intercept of negative 2, so I'll graph that point, and a slope of positive 5/2, so count up 5, 1, 2, 3, 4, 5, and over 2, and put a point, and do that as many times as you want to, or count down 5, 1, 2, 3, 4, 5, and backwards 2. Ask yourself what kind of line to draw. Since we are just less than, we are going to draw a dashed line, so use a folder, make that line go all the way through your graph. Oops, do better than I did, use a straight edge, use a ruler, and an arrow, so there's my line. And now the final step is that shading step. My trick only works if it's in slope-intercept form. If you want to see why, if you take a look at the original problem, you might be tempted, if you look at the y, to shade above because it says y is greater than, but that's not how the line is actually drawn. Once I've rearranged for y, it actually says y is less than, if I remember to flip correctly. So put your pencil on the line, less than means below, so go straight down from that line, and we end up shading this entire side of the inequality. All the points in this shaded region would be true solutions to that inequality.